This is a MOSFET, which is a very essential electronics engineering component. You definitely need to know and understand how it works, because whether you realize it or not, this small device is inside power supplies, inverters, laptop chargers, motor drivers, and even the phone you are using right now to watch this video. And the truth is, many students use it in circuits without truly understanding what is happening inside it. So today we are going to slow down, take it step by step, and break it down in the simplest way possible, so that by the end of this video you can confidently say, yes, I understand MOSFET. Now first of all, what exactly is a MOSFET? MOSFET stands for metal oxide semiconductor field effect transistor. And yes, I know that sounds big and technical, but don't worry, the name is more complicated than the concept. Because in simple terms, a MOSFET is a special type of transistor that is mainly used for switching and amplification, meaning it can turn things on and off very fast, or it can control signals in electronic circuits. Think of it like a very smart electronic switch, but instead of pressing it with your finger, you control it using voltage. That right there is the key idea, voltage control. Unlike a normal bipolar transistor that needs current to operate, a MOSFET is controlled by voltage applied to its gate terminal. And that is why it has very high input impedance and very fast switching speed. Now let's talk about its terminals. A MOSFET has 4 terminals: source, drain, gate, and body. But in most practical circuits, the body is connected to the source, so we usually treat it as a 3-terminal device. The source is where charge carriers enter, the drain is where they exit, and the gate is the control terminal. The gate is separated from the channel by a very thin oxide layer, and this is very important because it means almost no current flows into the gate. Instead, the voltage applied to the gate creates an electric field, and that electric field controls whether current can flow between source and drain. Now pause for a second and imagine this like a water pipe. The source is like the water tank, the drain is like the outlet, and the gate is like a valve handle. When you turn the valve, you are not pushing the water directly. You are controlling whether the path is open or closed. That is exactly how a MOSFET works. Okay, now let's talk about the most common types of MOSFETs. Although there are different classifications, the 2 main operating modes you must understand as an electronics engineer are enhancement mode and depletion mode. Let's start with the most common one, enhancement mode, also called e-MOSFET. This is the one you will use most of the time. In an enhancement mode MOSFET, when there is no voltage applied to the gate, the device is off. No current flows between drain and source. But when you apply a sufficient gate voltage, a conductive channel forms and current begins to flow. So in simple terms, no gate voltage means off, apply voltage means on. That is why it is called enhancement mode, because the channel is enhanced or created by the gate voltage. Now the second one is depletion mode MOSFET. This one behaves differently. When there is no gate voltage, the device is already on. Current flows naturally. But when you apply voltage of the correct polarity, you reduce or deplete the channel conductivity and can turn it off. So enhancement mode starts off and turns on with voltage, while depletion mode starts on and turns off with voltage. That is the key difference. Each of these modes can also be either N-channel or P-channel. N-channel MOSFETs use electrons as majority carriers and are generally faster and more efficient, which is why they are more common in power electronics. P-channel MOSFETs use holes as majority carriers and are often used in high-side switching applications. Now let's move to something very important, the operating regions of a MOSFET. There are 3 main operating regions you need to understand. The first one is the cutoff region. In this region, the gate voltage is below the threshold voltage and no current flows from drain to source. The MOSFET behaves like an open switch. It is off. The second region is the triode region, sometimes called the linear or ohmic region. In this region, the MOSFET behaves like a variable resistor. The drain current increases as the drain source voltage increases. This region is often used in amplification. The third region is the saturation region. In this region, once the drain source voltage exceeds a certain level, the drain current becomes almost constant and is mainly controlled by the gate voltage. When MOSFETs are used for switching applications, they are usually operated between cutoff and saturation regions. Now let's quickly talk about MOSFET as a switch. Imagine you want to turn a lamp on and off using a microcontroller. The microcontroller cannot directly supply large current, so what do? We use an N-channel enhancement MOSFET. When the gate receives a positive voltage above its threshold, the MOSFET turns on and allows current to flow to the lamp. When the gate voltage is removed, the MOSFET turns off and the lamp goes off. That is clean, fast, and efficient switching. MOSFETs are widely used in power supplies, DC motor control, inverters, SMPS circuits, amplifiers, and chopper circuits. Their advantages include high efficiency at low voltages, very high input impedance, and fast switching speeds. However, they also have disadvantages. Because of the very thin oxide layer at the gate, they are sensitive to electrostatic discharge. That means a small static shock can damage them. They also require careful handling in high voltage applications. So by now, if you followed step by step, you should understand that a MOSFET is not just a random three-leg component. It is a voltage-controlled device that uses an electric field to control current flow. It has different operating modes, different regions of operation, and plays a massive role in modern electronics. If this explanation made MOSFET clearer for you, then you are no longer just memorizing definitions, you are actually understanding electronics. And that is the difference between a beginner and an engineer. If you found value in this lesson, support the channel by liking the video, drop your questions in the comments, and subscribe to Damitech Electronics for more deep and simple electronics explanations. I will see you in the next one. Peace and love.